Hello and welcome to Next Day Solar. We're here in Newport in Wales and we've come to see a company called BIPV Co. And this is James and this is Lola, the dog, and I'm Asher. And BIPV Co. make some amazing things. Now, we're in this amazing place actually, which is an old, previously used factory where it made solar cells. So James is going to maybe just tell us a little bit about, I suppose, this room here, what we're doing here, and then a bit about BIPV Co. and the amazing things that they're doing. And they make the most incredible solar panels, which we use actually at Next Day Solar in lots of different things, and they're bendable. And we've seen the whole production process today. It's been amazing. We've all been blown away. So the start of this company was sort of this room here, which looks like a futuristic kind of robotic factory. What is this place?
So this is our old production line for a dye-sensitized solar cell, which is under the guise of G-cell, hence why the building is G-cell. But from there, we obviously then, unfortunately, that technology was a little bit old, so we obviously looked for the next best thing.
Was that because the voltage, the output of the cell, was it sort of just there wasn't a lot of current? Is that?
Yes, it was designed really for lower powered consumption. So things like mobile phones now have become like mini computers. So originally, like the Nokia sort of style phone, that would have been adequate to keep things charged. So it was designed really for sort of everything from like air quality sensors, peripherals. So it had a huge scope, but there were some sort of complications within the manufacturing process in terms of lots of wastage. So in terms of as a viable system, yes, it was going to be expensive, but you would have had to, obviously there would be lots of wastage along the way. So we then looked at sort of SIGs as being the next big thing.
You call them SIGs, and I've asked twice today already. What is? It's not a cigarette.
No. So
it's far from a cigarette. It's much cleaner than that.
Yeah. So it just sounds. So obviously, most conventional panels are either going to be a glass-based or silicon-based system. SIGs is a copper, iridium, gallium, selenide construction. So it's just a cell.
I could never say that, by the way. If anybody gave me an hour to practice it, I could never say that.
Well, obviously between you and I, nobody else can know this, but I couldn't say selenide before. So I used to go, what was it? So I used to just go SIGs, copper, iridium, gallium, and then stop. And people go, what's the S for? And you go, I don't know. Something impressive.
But so these are SIGs.
Yeah.
Right. Okay. Which is what you've just said there before. Right. Okay. And that means that they're wired up differently. Is that right?
Yeah. Right. So a conventional panel only has 3 bypass diodes. So if you were to shade, so if this was a conventional panel, if you were to shade one cell, you'd actually lose a third of its performance because of its construction. So what you'd normally have is diodes at the junction box end. And all it's doing is you actually have a row of cells, which then is cast as a string. You'd then have 3 strings, so all in parallel. But if you were to block one, obviously the current couldn't obviously sort of run through. So what we've done with our technology or with SIGs is that every pair of cells, you actually have a bypass diode. So if I was to shade that cells, this would work, that would work, and obviously still run through. So it wouldn't matter where you sort of shaded it, you'd still get a current to go through.
And were they designed to be shade resistant? Was that like, we've got it, was that the sort of the focus of it?
The reality is that it was designed, if we sort of step back to 2015 when the company was formed, so it was in partnership with British Steel, and Swansea University obviously helped with the development of the product. But the aim was a place like this, in terms of you have these large, if you look at solar farms, they tend to take up landmass. So in terms of, for us as an organisation, we realised that there are these huge cities, so London, Manchester, Birmingham, where you have you could make a solar farm out of a rooftop, which is how we really sort of formed. There are lots of complications which obviously you don't really think about in terms of landlords and the owner and the occupancy. But that's another complication. But that's how it was formed. It was designed to take shape of a roof. So in terms of it could be bonded onto a flat surface or a curved commercial roof. It could take multiple impacts. So in terms of strikes from debris or etc.
Bird poo pigeons.
Can be walked
common things in London.
And again, in terms of if this is left for a long period of time, most glass panels need a regular cleaning maintenance.
Rinse down,
So rinse down, you don't need that, so you're saving water. You're saving obviously on the health and safety, the construction side, the labour obviously element of it as well. It'll self-clean, as long as it's on a 3-degree tilt, water will pool off.
Which is nothing, most roof, 15 and
so we've got an ETFE top layer, so again, nothing will stick to it. So it was designed really for that. For me though, obviously I look after the commercial side for fleets and leisure. You could use the same model then in terms of, if you look at most commercial applications where they're putting standard cells on, they're not designed to take excessive vibrations. And obviously being on a road or a vehicle that's obviously not designed to be that rigid, you'll see lots of
cracks, potentially.
Cracks, microfractures, hot spots. They obviously, as a byproduct from most conventional panels, heat is an element of it. So SIGs doesn't actually generate, so it's part of its process, doesn't generate heat in the same sort of form. So again, we can be bonded directly to a roof surface without venting or raising it. So there are
and that's because they're in series and therefore they don't,
It just doesn't use
higher voltage, potentially less current, less heat.
No, it's because the so obviously with glass or silicon, as part of its harvesting, it obviously then creates heat.
Yes.
So these don't.
Right.
So there will be obviously it's dark material, so it will obviously generate heat being a dark material, but it doesn't as its byproduct. It's not. Right. There's no heat as a byproduct.
Understood. Okay. So you've designed a panel which is shade resistant. Well, it works much better from shading. I mean, that's a no-brainer, right? When you're installing on a roof, because inevitably you've got trees, you've got clouds, and that sort of thing, and then you can walk across a panel and you can see it drop off. Yeah. I mean, the thing that I love about this panel is that it's made in Wales, and you've taken us around the production, the factory, and there is like no waste. I mean, none. And I'm being genuine about that. From each step, there's a lot of, it's a very detailed process, but and also the very start of it, the cell. I mean, you were literally able to bend it round, and then you took a conventional panel cell and you just bend it and just bang, explode. So I was blown away by that today.
Well, this is why I spend most of my time. I spend most of my time telling people they need to obviously get bigger batteries as a commercial fleet side.
Okay.
That's the first bit, but the second side is obviously to explain when people go, what's the difference between yours and semi-flexible?
Yeah.
And you go, well,
this is totally flexible.
Well, semi-flexible really isn't. It's using two materials. So you've got a flexible backplate and a non-flexible cell. Yes. So hence semi-flexible, because it should surely be flexible or rigid. Because you can't have. I don't understand how you can have semi-flexible.
Yeah.
Because it's either or.
It's either can be bent or not bent. Yeah, and not a halfway house. And I agree with you. Most of the sort of flexible cells that you buy on the internet now, they can bend a little bit, but you don't know that. You actually don't know how much what you can do. Whereas with yours, there's a bit more confidence to be able to actually bend it around. You're going to go and do even more than I was about to do there, aren't you?
We ship them so they actually get shipped in a roll anyway. So as long as it's half a meter circumference, that's fine. But you can see the weight as well. So,
amazing. So
we're less than 3 kilograms per square meter.
And where do you see kind of the biggest market for your panel? I mean, we've been using it on vehicles, automotive, that sort of thing. I mean, is that the market, or is sort of house building? What do you see it as?
It's a half and half. So we've got two sides of the business. We've got BIPV Co, which is building integrated photovoltaics.
Right. This stands very well, by the way. This is magic. There's not like some magic behind it.
I work for MIP, which is mobile integrated photovoltaics. So for me, I see a huge demand within vehicles and fleets, but obviously again for the commercial buildings or domestic, there is a huge demand for that as well. But I think, truthfully, I can see the vehicles far increasing greater than the buildings.
But I think the on-cost for a vehicle is less as well, because you're not talking about a massive roof, you're talking about potentially a small surface area, and you're mobile. And, I mean, even your local electrician who wants to charge his drills could have a panel on the roof, and he'd come back in the morning and his drills would be done. Amazing.
Well, as I say, at the moment, I think we've got the I don't mean a luxury in terms of fossil fuels, but in terms of, at the moment, fossil fuels is there. But the minute they go over to EVs, you know in terms of with your own fleet, the minute you then put on lights, heating, ventilation within that cabin, you're diminishing your range. Absolutely. So this is why I think that once it goes to more, to EV vehicles, the minute they start using it either for refrigeration or commercial use, and they want that range or they need that range, I think this is where solar then becomes an invaluable asset.
And what's the first thing that, when you sort of talk to people about solar, what's the sort of thing that they say, no, it's just not going to work for us? Is there anything that sort of ever comes up and people, I mean, is it cost or is it understanding? What do you think?
So interestingly, on commercial fleets, and I've been doing this for years, so it makes me laugh. You go into a large commercial, I won't give any names, but you go in there and they go, oh, we don't have any problems within our fleet. Right. And then you ask them to go and do an audit on the vehicles or look at the battery replacement, alternators, catalytic converters, because obviously these vehicles are then sort of sitting idling, which they're not designed to do. And then you explain in terms of how much fuel is obviously then being used for ancillary services. Versus, because obviously vehicles are designed for propulsion. Correct. They're not designed as generators.
And are you being used as generators? Yeah.
But they see the cost as being free. So in terms of they go, well, that doesn't cost me anything because the vehicle's running. And you go, but you're putting an extra load on the alternator. Yeah. So they're also, more revs, more demand, and power is power. Nothing's free.
Absolutely.
So so that's the biggest challenge, I think, is education within the sectors. But it is there now in terms of, I think, that the great thing over the last couple of years is there are more and more people not using the best technology, but they're using solar. It is a journey, and I don't dismiss anybody from sort of taking that leap of faith of any technology, because eventually they'll come to us.
Sure. Well, I hope they come to you, because this panel has been made in Wales, whereas most other panels in the world are coming on a cargo ship from China. I think 90% of all solar panels are coming from your panel's 1 mil, 1.5 mil, whatever it might be, but it's like nothing. Whereas most panels coming on a rigid frame are like 40, 50. So the impact of buying one of your panels, and we have no affiliation, by the way, is so much. It's so much less than buying something from from Eastern Europe or the Far East, etc., which is what's so appealing. And the production process was brilliant to see.
Without being cheesy, but they're designed for UK weather.
Yeah.
As in, that's the reason that the team are here, and the reason we're sort of passionate about the product is we know that we've got a product that is suitable for UK weather. So we're a higher voltage than conventional panels as a VOC.
Right.
So again,
because they're wide in series.
Because they're wide in series, and also because the cells itself. If you look at conventional panels, you might get 20 or 30 volts maximum.
Yeah.
So we've got the largest panel we do is 340 watts.
Right.
And that's over 100 volts VOC.
Wow.
So again, the idea is that obviously, I'm going to speak from a commercial, from a vehicle perspective.
Yeah.
You need to be 1 volt above battery state to start charging.
Definitely.
So if you've only got 20 volts to play with in the first place, in the winter months, you're going to struggle to get there, apart from maybe that little small window of midday sun. So the idea of these products is they'll wake up early in the morning and stay charging later in the evening. So we've got the same efficiency as a standard glass module, but we've got all the benefits of being lightweight, flexible, durable. And that's the other thing, is in terms of with the construction with the bypass diodes, and this is from a commercial aspect anyway, if they were to sort of push this onto a vehicle roof, the vehicle then obviously has an impact with a branch, whereas a conventional panel will destroy it.
Yes.
You could obviously, I could sort of rip off 5 or 6 of those cells and still have a product that functions.
Which is a massive thing. Amazing. And I mean, me personally, we've cycled here today, not all the way from London to Wales, but we've cycled as much as we can. You've been telling us about your journey to kind of lessen your impact on the environment. Is this sort of a big thing for you as part of that journey, or? Yeah.
Truthfully, I think it is the reason I've done this. In terms of if I was doing previous roles before, it wouldn't be on my mind. And I think that we've got to take a stance. And I think I don't want to preach to anybody about anything, because I think it's your own individual journey.
Yeah, absolutely.
And to me, it's about everything from food, food, transportation, energy. I'm passionate about something. I don't explain what the passion is, because I think that
it's personal to everyone.
It is personal to everybody, but for me, this has made a huge difference in my life.
Amazing.
Because I do believe I'm doing a little bit good.
Well, I think you're enabling people to find a product that can essentially power their lives, be that their vehicles or their homes and properties. And I think these will appear on many more UK roofs in the future, especially because they're coming from here. Because I think people are much more conscious about where the products come from. It was actually one of the things that people often ask us is, well, where are your products coming from? Are they coming from China? Because if you tot up all the maths, you might have actually negated any positive benefit of actually using something if it's come all that way. So
agreed. And I also think it's in terms of for us, it's the longevity that we, for a roof, we guarantee this product pretty much for the duration of your mortgage. For a vehicle, we've obviously shortened it but we've tried matching it to the typical life of a vehicle. So again, that's something that is a one-time application, one-time purchase. It's not, and I think that's what, I keep reading articles at the moment in terms of Australia, in terms of landfill with conventional glass modules.
Wow.
And that's something, again, that you just think,
there's a lot of metal in it. There's a lot of mixed things in there, aren't there?
They can't really be recycled. There's lots of elements in it. You've got solder, which are non-toxic, but you've still got a product that is taking up landfill. The great thing about this, in terms of its construction, we know it's built to last, but you've got a chance, because it's obviously the thermal plastic, you've got a chance of being able to sort of delaminate it and take elements back out of it.
Using the cells again, perhaps.
And the metal backing. So again, the cells could be used as another thing if technology improves. So I do hope at some times we will have a reuse, like lithium batteries. 3 uses, we should have the same principle with a solar panel.
Well, thank you for showing us around the factory today.
My pleasure.
Thank you for showing us all the production process. It's been amazing. And we now know a lot more about this amazing, do I call it a BIPV Co panel or an MI? I mean, I think it's got BIPV Co.
I'm just a division of BIPV. So BIPV is the real brains behind this. I'm just a division of it.
Amazing. Well, thank you so much. We hope to see this whole factory taken over with producing these panels in the near future.
There'll be more panels, more dogs.
Yeah, great. All right. We hope you enjoyed the video, and thank you for watching.